So we're going to talk a bit about agents and actually talk about just one use case. I don't want to be too long, but actually the use case is a class of use cases because we're going to talk about software development, using agent in software development, and I think there are so many use cases over there, and I see in front of me like a really amazing group of people that probably working on different angles of this use case, and so I'm expecting like really cool discussion later on. But let's start with agents. I'm going to do it really simple. Like I hope I managed to make it like agents for dummy or something like that, but really simple. Agent GPT or agent LLM, because there are also other kinds of agents, like one that running in your server, etc. So agent LLM or so refers to an autonomous AI-based program. Okay, that's I think the first part, capable of interacting with configurable environment. Okay, well, that's what we hope. That's part of the suggestion here for you, and tools to complete requested tasks. Okay, that's like how we see it. We're going to go back to like a really high-level architecture in a second, but first I want to explore different aspects of agents. So first, like an agent could be a single agent. It could be many agents working together. When you think about many agents working together, it could be like a super agent, a main agent, or something like that, coordinating a few other agents working together, right? Or it just could be like an agent, a swarm or so. Another dimension, we can think about it like agent generic versus specialized. Let's take the very specific case where we have many agents, and you could have a super agent. The case where there's a super agent and additional agents. Let's focus just on that for a second. So when we're considering generic versus specialized, we can think about a super agent with additional generic agents. In my opinion, this is roughly what's going on right now in AutoGPT. Or we can think about super agent that actually utilize a few or many specialized agents. And what are these specific agents and why are they different from each other? I think that when we're going to talk about the software development case, we might shed some light on and see that there might be different specialization. It could be from different integrations. It could be because of different data that each one has was exposed or is exposed at a given moment. Okay. Now this is the most simple diagram I could think about. Really, like I try to simplify as much as I can. Really dumb simple of what is agent in general. And I think like the agent is basically, it's a core algorithm that can think, rethink, reflect, use tools, decide, criticize, and basically it uses different type of tools, and the tools opens a new dimension, like the environment. Each tool also brings a different environment. Like if it's a tool that enables you to browse the internet, then this tool exposes you to a larger environment, etc. And then there's the memory. We could put the memory inside the tool, but I think like it's so important tool by itself that we can separate it. There are other tools that you can think of that might think that they deserve a category by itself. For example, maybe knowledge base, etc. I can put it inside. I've decided to put it inside memory or tools. And then finally, maybe the most important is that the agent has an interface. It could be a user interface, like for a developer, or what Toran talked about right now, a user interface for anyone, basically having a mobile app or a web app. But it could also be an interface to another agent, right? So this is the most simple like diagram I could put in on a slide. Does it make sense? Like I think you asked about it before. You were good? Okay, cool. Now, I want to talk about a specific use case, which is software development. Using agents in software development. First, I want to tell you a personal story. So I was a co-founder and CTO in a startup called Visually that was acquired by Alibaba, and I opened Alibaba offices in Israel. And in Alibaba, you were really pushed, although it's a corporate, it's a really, in my opinion, an amazing one. You're pushed to develop really fast. Like they're try to keep the startup environment, culture, like change is the only constant is the theme there, and we're pushed to develop really fast. And then one of the teams one day pushed to production something related to one of the e-commerce app, and basically turned blank one of the main areas for 1 minute until that was discovered, and that cost like $10 million or so. And so that, like, at that point, when I'm thinking about it, like, I mean, like, it's very important that we could develop fast, but at the same time, we probably need to do that with confidence, right? So I think like AI could help you develop fast, but also with confidence. And that is part of that. Remember the story, because I think it has a lot influencing the future that I'm going to show you, that how I see the intelligent software development future going to look like. So first, let's talk about the software development process Gen 1.0. It's not software development 1.0, rather the process 1.0. Okay, so I think like traditionally or commonly, what we do basically, we write some spec. It could be, if you're a backend developer, maybe it's some ticket or document or whimsical or whatever. If you are a front end, maybe it's a Figma or anything like that. And then usually what you do is from there go directly to implementation. Maybe you break it down to another dev ticket or so, right? But then you go to an implementation because you're being pushed to develop fast. And the next important thing is the code. And after you do that, if you have enough time, then you also write some tests in order to verify that what you developed is working like you meant to. And on the y-axis, you see executable, like Spec, for example, is not executable until today. We'll talk about it. And code is executable, and test is somewhere in the middle. Like it's executable, but it's not application code, right? And then the x-axis is time, like how usually you would develop things a long time. Okay, so I think this is a classical common way to develop. Do you agree? Okay, cool. And I think sorry, and one more thing to add here is that right now, although there are really cool dev tools that already exist, such as GitHub Copilot or any other tool that you're using. I didn't know if I start naming other startups, if I will be called out that I forgot one or so. So I'll use only, but they're really cool startup doing dev tools with AI. I think like they're fit inside this paradigm of Gen 1.0, but it does jump to Gen 2.0 with assistance. Okay, like you have an assistant for code completion, for example, Copilot, right? And maybe there is assistant or not out there for helping you to do specification, etc. And then the question is like, is there an ideal way to do it otherwise? So I'll just, for the sake of the conversation, I would say that some people would say that maybe the ideal way is TDD. Now I'll raise hands if you agree, if you don't agree to it. Okay, so for those online, most people do not agree that TDD is the way to go, and I think like there's many reasons why not, and one of them is that it's really hard to practice. We're missing tools to do that, and there are many others. By the way, I removed the time axis because now it's like done with the errors themselves. Okay, so the question is this ideal way to go? Maybe yes, maybe not. How I think about it, how we think about it, at least at Codium, is that you should actually be able to do it any way you want. Okay, AI could help us to do it any way you want. You could start from the spec, you can start from the implementation, you can start from the test, and then there will be agents that will help you to complete all others. I guess you're all familiar with the dry concept, where you don't want to repeat yourself with code. So why do we want to repeat yourself with spec or test and code? And I think like there is some redundancy, but it's not totally redundant. Okay, because spec is not code. When you work on spec, you want to define what you want to do, but it's not as detailed as code, because if it is detailed as code, it's code, right? But you do want to start with some specification. Also test. Without the test, you cannot really verify that the spec and implement code is actually fits. But there is a lot of redundancy there. So what we think is that basically with AI agents, eventually you would be able to start wherever you want, and the AI agent will help you to continue from there. Here is an example of some things that you can do already today with AI agents. This is the future, and it depicts a case where agents, like at least like I could think like agents are equal. Like we're talking about super agents with agents or agent swarm the swarm of agents that are similar. They're not specific. They're generic. And specifically, what I think is that we will have designated specialized agents that are really good in doing a different task. And this could be because they have different integration, even into different software, to Jira, to your production, to your app running in production, etc. So we'll have specialized agents. And actually, what you see here are like agents that you can already find. For example, in CodiumAI, you can find already a few of these agents that I'm showing here. That is going to demo like my partner is going to demo like in 2 minutes, and you will see like agents also helping you, or if you want like capabilities helping you, because it's not a fully autonomous agent right now. So capabilities helping you closing, like having tests and improving the tests, like closing the pipeline, closing a feedback loop. I'm jumping now to something else. To summarize, so far, I think software development is an amazing use case for development of agents, and you can think about it like agent helping you to take the dry concept to the extreme, aligning between specification, code, and test, and then we believe that these agents will be specialized, and I think like one of the things we're going to do in the hackathon is try to create a few of these agents, use AutoGPT for some of these processes. For example, a PR reviewer, automated PR code review is meant to verify that the code is according to some specification, to some definition, or to some best practice, which I also call the spec, because spec could have a line of, here's our best practices. Now make sure that this PR is according to the best practice. So that's the point. And I want to jump to something else, which put some, like I want to explain why I think like all of these three are important. So I hope it's clear why we think spec is important, and it's part of it what you asked before, David, right? Like a spec is one of the places where a human can ask what they want from the agent. So I hope like why explaining why spec is important is clear. I don't need to explain it, right? And why code is important also clear, right? Because this is what we want eventually. And now I want to explain why I think like tests will not disappear so easily. They might change their form and what it means. Like I don't think there will necessarily be call tests, but something that verifies that spec and implementation works as expected will exist. So let's talk about GPT-4. This is a figure that was published by OpenAI themselves, and they show like the amazing improvement between GPT 3.5 to 4 on different tasks, and some of the tasks like they reach to a level where they pass exams and maybe better than the average professional, which is amazing. But I noticed that, and I think many others noticed that on the Code Force rating, which is a competition related to developers, like for programmers, they reached a fifth percentile from the bottom. And why? Like GPT-4 is amazing in coding. It doesn't make sense because we use it every day, right? In one way or another, or some other LLM. Okay, maybe you use like other startup product and it works well for you, right? For programming. And GPT-4 is probably as good, if not better, from others. So how come this is the score? Okay, so I'm going to try answering that. So here we see AlphaCode system, and they reached the 54 percentile, much better than the bottom 5 percentile. And the question is why? I'll explain a bit. What you see here on the left is like how the competition looks like. Sorry for if it's a bit not zoom. I'm not zooming in. I don't want to ruin right now the presentation, but you see on the top, on the left, on the top, you see a natural language description of a problem, like a spec. Okay, on the bottom left, you see the code implementation, and they brag about it, why it's good, and they have all the reasoning to brag. It really works. They reach 54 percentile. And on the bottom right, you see their diagram. I'm not going to dive into it, but basically, like almost the entire solution here is like training, is about creating an LLM, creating a code generation API, okay? Like they take the GitHub data, they actually fine tune it for the specific case, which should be even better for the specific solution, question answering like data set. And then for each problem in the competition, they use this large language model to create not one solution, but actually create 10,000 solutions, sometimes less, sometimes even much more. And then they use another machine learning based solution to verify the code. So probably a lot of those solutions that were given like out of the 10,000 solution, I think maybe many of them are actually not so bad. Like a developer could take it and tweak it to make it useful and solve the problem. But this tweaking involves a lot of intelligence that we're so surprised by the amazing result we get from the LLM, but a small tweaking that we do is actually what makes the code work. And if you really try to automate this process, then most solutions do not work. The past 10, I'm talking about, actually drops underneath GPT-4 1. So in order to reach to their amazing achievement of 54 percentile, they add another part here on the right that actually automatically verifies does the solution fits for the spec. Is the code and spec are in fit? And I think this is actually like the competition is 101 programs. They're like CS 101, like bubble sort, a bit more complicated than that, but not much more. If you think of real world code, then this is probably even more important, okay? So basically, the agent that we're building right now, not open sourced, but it's basically like a working product, somewhat similar to small dev, but inside your ID, like Swix is here with us if anyone is online. So some working inside your ID, and we're going to show a demo. What we're trying to create is that code integrity agent, that specific agent that maybe could work with other agents as well, that focus on having 0 bugs. Like if there's those company that try to reach 0 emission or so, we want to clean the internet from bugs and reach 0 bugs. That's what we're trying to do.